Hi everyone, it's Mrs. Palmer here. Today's Wednesday and today we're going to be looking at 3D shapes and recognising the nets of 3D shapes. I don't mean nets for catching fish or nets for the back of a football goal. We'll have a think about what a net is in mathematical terms in a moment. But first of all, we'll have a little look at some of the shapes that we've looked at this week. So I'm going to ask you to pause the video, try and be honest, pause the video and see if you can name some of these 3D shapes from yesterday. Hope you paused. Okay, here are the answers. First, we have that little yellow shape. That is a cube. We know it's a cube because it has 6 identical faces, which are all squares. Then, very similar because it has 6 faces. Lots of right angles and vertices, lots of parallel faces, lots of perpendicular faces, so faces that meet at 90 degrees. It's a cuboid, but what makes a cuboid different is that it is a mixture of rectangles and sometimes squares, okay, not just squares. Then we have a triangular prism, one of my favourite kinds of shapes. You know it's a prism because it has an identical face on either end of the shape. If I were to slice it like a cucumber, I'd get slices of the same shape. Doesn't change size, doesn't change shape at all. It's exactly the same from the front face to the back face, the parallel faces at the front and back. I've got another example of a prism on here, which we'll come to in a moment. Here's a cone, which has a curved face and a 2D circle for a face. It's got 2 faces. We actually call curved faces surfaces. They're curved surfaces. Normally faces are flat, okay? And we have a square-based pyramid. Because triangles meet at a point, like a pyramid you would see in Giza in Egypt. But it's a square-based pyramid because its base is a square. Then we've got another prism. This time it's an octagonal prism. So the slices all the way along, like a cucumber, are octagons. So there's 2 octagon faces and the rest are rectangles. And then the cone. Oh, sorry, I've done the cone already. Now, Mrs. Palmer is going to show you a short video that will hopefully explain a little bit about what nets of a 3D shape are. So make sure you're really concentrating.
Here's the 3D crew. Looking good, guys. Yeah, if you wanted to construct your own 3D shape, you would do it by first drawing a net. This is what the shape would look like if it was opened out flat. Now, if only there was some way to see these guys' net forms by flattening them. Bit harsh, but thank you. Great examples of nets here. Luckily, of course, the nets can fold back into their 3D shapes. Well, most can. Spheres are a funny bunch. It's pretty difficult to make a net of a sphere. Still looking good, though.
So a net of a 3D shape is what it looks like if it's opened out flat. A net can be folded up to make a 3D shape. There may be several possible nets for one 3D shape. You can draw them a net on paper and then fold it into the shape. Now, that's going to need your imagination. You can actually create them on paper and have a go yourself. But most of the time, we need to try and imagine that shape opening out or closing back up to create that shape. I'm going to show you a couple of examples of what that might look like. So here is an open net of a cube. Now, Mrs. Palmer's going to use this tool to close it back up and hopefully be able to see. So at the moment, this is a cube. I know it's a cube by using my noticing skills and remembering what I know about a cube. What do I know about the properties of a cube? Well, it's got 6 faces and the faces are all identical squares. So if I look at this net of a shape, this opened out cube, I can see that there are 6 squares that make up that shape. I don't know that this net will make a cube yet before I imagine it closing up. This tool will help me. So I'm going to close this up and you should hopefully be able to see how that net then looks closed and open. Okay, have another look. I'm going to close it up again. There it is, open, all flat, like that video I showed you then, and I'm going to close it up. And all of those different squares then become faces of the cube. Okay, I'm going to show you another example. This is a rectangular prism now, or a cuboid. So here's the cuboid. I'm going to move him a little bit so that you can see him. And I'm just going to find my open button. I can't see it because I'm on the screen with you. Here it is. Here it is. I'm going to open it up, unfold it, and you can see that this cuboid, this rectangular prism, is made up of all those different rectangles. Okay, I'm going to fold it back up. You can see how it can open and close, and it creates that rectangular prism. Okay, now this one's a little bit trickier. This is a prism again, but it's actually, let's have a look down to the side. Before I tell you, let's see if we can look for clues. So I've got rectangular faces all the way round, and I've got two identical faces on the top and the bottom, so that's what makes it a prism. Imagine if I can slice it like a cucumber, they would always be the same size and the same shape. So I've got 1, 2, 3, 4, 5, 6 faces. That tells me it's a hexagon, which tells me it's a hexagonal prism. Now I'm going to open this up, and I would expect my net to show me rectangles and hexagons. So I'm going to open it up using this slider here. Whoa, it's a bit spectacular, this one. Splat. Opened out flat. I can see those two hexagons that make the top and the bottom, and then all of those rectangles. Let's count those rectangles. 1, 2, 3, 4, 5, 6. So my hexagon has 6 sides, and I have 6 rectangles to create the prism. That's not a coincidence. You might spot some of those patterns. Perhaps a pentagonal prism would have 5 rectangles. Perhaps a triangular prism would have 3. Okay, so there is a relationship. Look out for that when you're spotting the nets today. So here's an example of what I just mentioned, the triangular prism. I've got 2 triangles at the top and the bottom because it's a prism. And then I've got 3 rectangles. That's because my triangle has got 3 sides. So those rectangles will help make that prism shape. So here it is when it's all put together, triangular prism. Now the next net I show you, I want you to see if you can try and guess what you think the shape would become. Have a little look for clues. So I've got 2 squares and some rectangles. Try and visualize that shape folding up to create the 3D shape. Try and imagine it. And here is the shape it would make. I wonder if you were right. A cuboid. Okay, so it's making up those different shapes by folding them up. Here's another example. This is a bit weird, this one. This one's made of 2 circles and 1 very, very long rectangle. Think about it folding up. Some of you might recognize this as a prism because of the 2 identical shapes at top and the bottom. Well done if you knew that it was a cylinder. So cylinder's like a can or a tube, like a Pringle tube. Cylinder there, you can see now that big rectangle in the middle there will actually fold to become a curved surface. That third part of the 3D shape, top, bottom, and curved surface around the middle. Okay, I've got one more. Now, this is a cube. I've told you it's a cube because there are many different nets for making a cube. You know it's going to be a cube because of the 6 identical faces, the 6 identical squares, but you don't know if it's going to be a successful net of a cube until you imagine it folding up, or perhaps you cut it out and have a go yourself. Now your task today is going to be about recognizing the 3D shapes and perhaps recognizing the nets of those 3D shapes. Now that's quite a challenge, okay? So have a go. There will be bronze, silver and gold. Gold is trickier, silver is in the middle, and bronze might be if you're finding this a little bit difficult to understand. But have a look because you might find that you'll be able to have a go at all 3 perhaps, okay? Or just 1. Have a go and have a look. Now, our mystery fact, I've been really mean and I've saved it right till last. Our mystery fact is this. It's about a 3D shape. This cool shape is a dodecahedron. Now, we've heard of tetrahedrons and hexahedrons in the videos earlier in the week, but a dodecahedron is a 12-sided or 12-faced 3D shape. A dodecahedron doesn't have to look like this one on the left. As long as it's got 12 faces, it makes it a dodecahedron. There's 2 examples there at the bottom. Both of those shapes are different. Both of them are different, but actually they are both dodecahedrons. So there's your mystery fact today. A dodecahedron is a 12-faced 3D shape. Good luck today, everybody. Thank you so much for listening.